For those of you that have never seen one of these, this is a Spencer pump action shotgun. It's big, it's clunky, it's jank, it has all kinds of really weird angles in it, and oddly it works. After Spencer got in a little bit of money trouble, Bannerman's bought all the production patents that made this gun in about 1907. So this one is actually parts complete and just needs to be trimmed out because it's, well, old. The one on the bench, on the other hand, yeah, that's where we're at today. And let's get on down the rabbit hole because this one is going to be deep. Follow me. Well, here it is, man. The rabbit hole. We don't care about a screw for my fox. We've torn this Spencer down, and one of the reasons why I was able to get into this gun as fast as I could was that Bruno had done an animation on how this thing works. So Bruno and C and Arsenal had actually gone through this gun once, and it's a fascinating episode. You should go watch that. In the meantime, what we discovered was this. There's a spring that holds this shunt gate, and that spring's supposed to come all the way back to here. We'll talk about that. That's broken. There was a custom follower made for this, for the magazine tube, out of something non-magnetic. I don't know what this is. It's like a piece of lead. I don't know, pewter. That doesn't work. There's a ejector gate here, extractor, ejector, that has a piece that kicks the shell out and then has to skip back over the shell. So there's a spring-loaded plunger in it. It's just flat out gone. This piece here is just cracked all the way around. See that crack? And this is that rubber, that gutta percha stuff, hard rubber. It's not gutta percha. It's different. But we got to fix this. And then there's some just trimming issues. Their migratory bird plug stack started out with a wad of paper, transitioned to a stick, and then wound up in a shotgun shell that is so old it was still made in Connecticut because it's a Union metallic cartridge round. So this whole thing has been around for a while. I will say this, and we're going to dive down and we'll make this screw first, and then once I get warmed up, we'll go after the other stuff. Manual of arms on this gun is dramatically different. So the whole time we're going through this, we're going to be talking about, just how they casually machine the breech block on this thing. Superficial resemblance to a Madsen machine gun should be ignored, but this whole thing is popping up and down and is one gigantic casting. And it would have been fascinating to have been fly on a wall when this thing was being made. All of our trigger parts, pivot number 1 is here, pivot number 2 is up inside here. All that's correct, so we're good. So what we got to make is sitting right here, and once we fix this, make this gizzy, make that spring, make another follower, and fix that, we might be able to make a go at making this thing work. The other problem we're going to have is this is a black powder gun, so we're going to have to. It's a black powder gun that is very overall length of shell, very sensitive because the shells are actually part of the feed system in this. So I don't know yet. We're going to get the gun mechanically right yet, and then I'm going to figure out where the heck I'm going to get some, we're going to make some black powder shells. All right, let's keep moving here. Well, I found myself a piece of metal here, and we're going to have to punch 2 holes in this. So what we're looking at duplicating, we're beginning to duplicate this on this piece. So all I do now is warm it up enough, make it turn a dull red, and draw the temper on it. We'll come back and retemper because it's going to have to be a spring. And for right now, it'll be a lot easier to drill holes in if we just heat it up and draw the temper on it. So humor me here. One of the things you got to keep in mind when you're heating steel up and you're using a vise to hold it is the thermal mass of this vise is huge. So it will draw heat off at a rate that can actually harden steel. So in this case, I'm not worried about it because I don't care about what's going on down here. I care about what's going on up there. All right, so the point of this is, I don't know how well this is going to show up, but there's a schmutz mark right there, and I know what this spring used to look like. This spring is what keeps the gate down. So when the peg from the operating bar comes back, it rides up over, drives the breech block down, comes around behind it, and then this pops up out of the way and lets it set back in the beginning again. So the first thing we found was screwed up was that this spring was broken, and I'll tell you, it's been broken recently because that is a clean brittle fracture right there on the very end of that. And not only is it a clean brittle fracture, but it's I mean, still shiny. It's right there, and it popped. So we're going to make another spring. Okay. It's still kind of warm. I'm just going to pick that up and dunk it in some water. See if I can get through this with the feeling and all of my fingers intact. There's a curl to this spring, and the tip touches the inside of that boss right there. So I'm trying to replicate that curl, and this is definitely a cut and try kind of deal where I'm just holding it up against the old part and cutting it out. And so far, so good. I'm right about there. So if I replicate on the back side what I've got on the front, we should be good to go. These holes are about 225 apart. You come to one end of one and one end of the other. So now I know about how far apart I want to put the holes in. I'll get a center punch here. Oh yeah, it's nice and soft. And we'll go 225 away. Let's put that in. So just barely touch it. Scratch it a little bit so I can see where I want to hit it next. Come up, put that punch right there. Okay, so now I've got, you see those two pinholes there, and I've pretty much replicated that. Close enough, we can tweak that in with a needle file while we go. But all I'm trying to do is replicate this spring, so I'll just keep on hooking away here. Okay. I'm doing all this optically. I'm just coming in and saying, the last spring was square, which was an odd choice. I'm going to make it square, and then when we're all done, I'll heat it up and bend that little profile in it. And that's when we'll quench it and get it in the pot of hot oil. And before I cut that, I'm going to drill these holes. And the reason for that is I want to have this thing be a little bit thicker so that when the drill bit hooks up, it doesn't screw me up as bad. See, we soften that up and this drill just goes right in. When it does that and your drill motor rides up the back, that will result in a broken drill bit. You got to try to put this thing in a place where you can get to it, hang on to it, but when you plunge in, the drill bit doesn't get snapped. So far, so good. They're close. We have to move them together just a bit, but it's not going to be that big of a problem. That's just a set of rivets. We're going to run these pins through and crimp this thing up against the wall. So now we cut to a square right there. Okay, I gotta go in front of the camera here. I don't have this jig. I don't have it jigged right. I'm coming right down the tape where I want to come down, but what I want to do is wind up cutting this square right about there. So what I want to do is this. Okay. Sort of working blind here, but trying to get this shaft down square, so I had to come in actually a bit more. Square would be right about there. Again, we're working blind here because we don't know what the original spring. We kind of know what it looked like, but we really don't. Okay. All right. And we will finish that up on a grinder. Be right back. So as I'm grinding, I'm bringing the profile on the top down to meet the profile on the bottom. It'll all line up on the holes. So I'm almost there. I'm doing this on a grinder right now to go ahead and pull into the end. And then the last thing I'll do is I'll do it with files so that I don't have grinding marks cutting across this thing this way, because we intend to flex it. It's going to get flexed this way, where ordinarily a spring like this would be flexed in and out. This one's going to be that way, so I got to make sure I don't have any cross marks up there. So now we just about got the profile. I'm just over kissing it on a grinding stone, but I'm not making Bruno move the camera. All I'll do now is round off the back end of it. We're pretty close, and we'll get it to absolute final taper here with some files. And we're pretty close. We're pretty close. I'll just kind of clamp that there and take that off smooth, because that's how they wanted it. I'm not trying to do an exact copy of what they did. I'm just trying to get the functionality right. Just trying to get the functionality right. There we go. And then a little more off the top, and I got it. There we go. There's a hole here, and this pivot pin goes down in that hole. Hang on a minute, let me get this in here, and then my hands will get out of the way. So this pivot goes here. So when you pull the breech block backwards, there's a knob on it. See it? This round knob, since this is spring loaded down, the knob must go up over the top, which causes the breech block to be thrown down. As the knob gets all the way to the rear, it comes around the corner, and then it will lift this gate up. This shunt will come up, and the knob will come through this hole. Now, I'm not pushing this down because I don't have that spring touch down, but the knob will come up, and then when it's sitting right here, it has the firing pin presented at the rear end of the shell. So it's kind of like a Madsen. It's a down all the way up, halfway back down again. So that's what we're shooting for. And what we needed was this spring that we're fabricating right here. We need that to be pushing on the top of this to hold this gate biased in a down position. So what I was doing was going in there and just hacking this out of a solid block of steel to get close to the original profile. When I feel good enough about what I think we got, here's the problem. We got to tack this thing together, and we almost have to put the rivets in and then just hope to God I got it right, because I don't know. The only thing I'm going off of is this. This is the one time you don't clean schmutz off. I mean, really, see that shiny spot right there? That's what I think the part looked like. So yeah, kind of like that. So that's sort of where I'm going. So the next thing I'm gonna do is make up a couple of longer pins for here and here, and trumpet the heads, and then just kind of stick this thing in and see if I can get it to sort of be right. And then we're gonna go ahead and put a temper on it. And I'll see you back when it's time to temper it. This is the part I've made. I've kind of got it scabbed in. I'm using nails for temporary rivets because they're really soft, and I can just set them, bang, bang, and set them in a hole. And what we were looking at doing, we have to keep the nose of the gate. We have to keep the nose of the gate closed. And we'll see here. So I've just bent this kind of on spec. And we'll see if we're even close here. Let me get a hammer. And see, I got a little bit of spring tension on this. And this is without the spring locked down. The rivets have not been fully seated. And we don't have any temper on the spring. So I'm going to call this pretty good. I'm going to put a little bit more of a, but I mean, it's holding it, almost holding it all the way shut. Whoa, lots of hands there. It's almost holding it all the way shut upside down. So all I want to do is get just enough preload on this that it'll hold that gate shut when it's upside down, so that the roller doesn't crash. You know, as you're coming to the rear, this rides up that, comes back around the corner, which I don't have this nailed all the way in, and I don't want to. Hang on a minute. Can I get this over there? Yeah. And it'll come around the corner and then come up through the gate and reset to go back in again. And when the gun's locked shut, it's locked shut right there. You're asking this little titty here to do a lot of work. And on the Bannerman one, this is actually a roller. So they did a little bit of updating on it. But I want to get this girl running first so we can get them both out on a skeet range. Okay, hang on now. We're not quite there. Okay, we're going to keep going, right? Okay. Tell you, that thing, man, when that goes in that hole, it wants to stay there. Okay, so what we're going to do here now is we're going to drive this off. It's a little bit too big. I got to get a slightly smaller. Here we go. All right, we'll just drive these out. That one came out, and that one came out. So now I get my gate back. So the first thing we're gonna do before we even heat treat this is we know that it's mounted in this format right here, because you can see that little uptick. So it's mounted in this uptick format, which means on this side of this, I'm going to take a countersink right here, and let's not use the breech block is what I'm going to be up against. I'm just going to, wait a minute, where's my lead block? Here you go. Get yourself a cake of lead and have it up on the bench, because it lets you do this. A little bit more. See, now if the countersink penetrates through, you can see that little silver mark. Who cares? Okay, so I put just a slight counter on that. So I've got this hole doing this. And then on the other side of the gate, on the outside part of the gate, I'm going to do the same thing. So when I put this rivet back in, it's going to be easy to just upset and fill this area, and it'll draw it all together, right? So in this particular case, I'm just going to do a little bit here, A little bit here. And I mean, just the tiniest little silver ring right there. You can see right at the outside of it. You don't want to overdo it. You don't want to make them too deep. Just want to knock them down there. So what I'm doing here is just, you see that little bit of red, that orange gloss on the other side of the fire there. You don't have to get it that hot. You just have to you got to bring it up above the point where it's not magnetic anymore. Always have a pair of dedicated pliers that have already been ruined, so you don't have to worry about ruining them. We don't need this spring to be hard as a rock, so we're just going to quench in oil, and we're going to oil quench like that. We're just going to knock it in there. Now when you quench in oil, it takes longer for the spring to cool down, as opposed to quenching in water where it cooled. The rate at which it cools down is much, much faster. All right, so now we got to get up in here. So inside of this cup is a little bit of motor oil, just a little bit. You don't need much. Let me shove this out the way here. What we're going to do is create a high carbon environment around our spring, and we're going to draw the temper back. So you can see I've got the spring up in the plenum here, up where the flames are going to be. You got to heat the oil up first. The oil won't, like oil on ships and stuff won't burn at room temperature. You can sit here and put the fire on that oil all day and it won't burn. So you got to warm it up. Then you get it to a point where it'll burn by itself. And I'm going to put a little more heat on it. And there we go. Now we're to the point where it's giving off enough of its own heat that it's heating itself up. The oil's evaporating into a vapor, and the vapor is burning. Oil itself really won't burn unless you get it good and hot. Okay, so to demonstrate, this is the oil tank that we're cleaning. I can just sit here and I can put a torch on this oil all day, and this is the same oil that's burning up in the can. You have to put a lot of BTU into that. It's a problem they're having with a lot of these old ships. They never defueled them, and the fuel oil that's in them has to be heated, but you can't heat it with boilers that haven't been running 50, 60, 70 years. So now you're in a bit of a conundrum. How do you defuel these things? Anyway, this is how the black powder guys temper springs. And all I'm trying to do, we came up above the temperature at which it's not magnetic anymore, which is about 1350 degrees. Quench, bring it down fast so that any of the carbon that's in the matrix is caught on the outside and makes it a rigid structure. But it's so rigid, it's brittle. And then you got to bring it back up to 450, 500 degrees. And we're doing this in a high carbon environment. Before you start a fire in your shop, you better make sure it's ventilated. This shop, we have 2 blowers running at all times, blowing expensive air out the back wall of this place. But we actually are ventilated. We have 2 egress paths, and there's a fire extinguisher about 5 feet away from this fire. So before you light a fire in your shop, think about what happens if that gets out of the lab. Let's say, for instance, somebody walks by and knocks this thing on the floor. Just beginning gunsmiths, you better think about the negative outcomes of stuff before it happens. All right, so I've got my rivets just kind of tacked in there. They're not all the way to the bottom yet. And this is the recess that's got to go in. So what we're looking at is touching the top of that recess. and putting this pin in. So we're just going to check and make sure, and I got to load it a little bit. That's a good sign. You're kind of guessing blind here. Right there. Wow. That bad boy does not want to go down. Oh, there we are. There we are. Now we're down in it. All right. A little bit more. Now the side of the receiver will be there, but that's what we're looking for, is that gate to be just there, and it doesn't hang open when we're upside down. So I've got it all pretty much the way I want it. Good. Now we got to take it back apart again and do one final thing. Give me a punch, please. Bruno's going to hand me a punch. Excellent. Because I got all the slop sucked all the way out of this. So the way we're going to sit on these rivets once and for all is we're going to take this rivet set, we're going to put it here in a vise, and we're going to sit down on this. And when we did that, these smashed down flat and these smashed down flat, and we are now home for good. So we'll put this back in, and then we'll call this the first thing that had to be done successful. Okay. Gotta lift it up a little bit. Put the pin in first, and then get the spring to set down. Lift that in. And don't want to run it down hard, but there we are. So now we started off with a piece of spring steel, and we wound up replacing a broken part. This has to be in here. Yeah, it should work with gravity, but you can see where the ball was starting to crash here because the gate would be partially up. And okay, so those crash marks tell us that this has to be spring powered. Okay. So that's the first of multiple things that have to be done to this gun. Let's go to an animation here and watch how this is supposed to work. Let's take a look at this piece of the gun. So if you keep your eye on the blue ball here, the hammer will fall. The blue ball causes the follower to cam down. And then when the blue ball comes back forward again, the spring-loaded gate's going to let it by. So there's the spring we just made. Does that look familiar? Yeah. So now when you push the slide back forward again, there's a lot of other stuff going on in this gun, but I'm only, boom, right there. So it can only go one way. It can only go around clockwise. In the past, I have made a comment that if you can't draw it, you can't cut it. Learn how to draw. Don't just get up on a mill and start rocking. Speaking of which, Rick took a shell cutter, Machinist Rick took a shell cutter for us, and he's going to square up this piece of stock. Now this has been sped up a lot, so you machinist guys, don't freak out. There's no way he's running a shell mill this fast, trust me. But we're going to do both sides, so now we know that the wide side on both sides are absolutely perpendicular to each other. We've got this thing sitting up on a set of parallels inside the vice jaws so that we know that it's square and it's being held onto. So now we'll come in and square up the narrow sides. And we're just nibbing off just all the rust and all the gack and just making this thing square. So all those numbers that we calculated actually mean something. Here it is. We got the fourth side. I'm having Rick do this because I don't know how to hold on to a part this small. All right. So now that we've got all that square, we're coming in and we're cutting off a step here. And this is going to be the feed surface. This is the part that grabs the shell and shoves it in the chamber. Just remember, boys and girls, the breech block on this thing doesn't move in and out. So we got to shove the shells in and out. In this still photograph, you can see on the left by his thumb, that's what we're making. So that surface, that vertical surface that he just cut, is what's going to grab the shell and stuff it in the chamber when this whole assemblage is in the right place. We're going to get to that in a little bit. So there's a recess in this block for a spring-powered ejector. So now with this woodruff cutter, we're going to come in and cut the recess for this. He'll probably bump out and move the workpiece over to the left just a little bit, but not much. This is the tool that I wasn't really entirely positive on what kind of loads it puts on the part. And I'm gonna say, as a gunsmith, 90% of machining is knowing how to hold on and work. So now we're cutting the step in the part here for where the actual ejector is going to be. And when we're all done, we're going to wind up with a hollow part that has a spring-loaded ejector in it and a fixed fixed feed pawl. While we have it in the vise and we know where it all is and everything's been located, we're going to go ahead and drill the pinholes in it. This helps a lot because, you know, we've got the digitals on this thing, and it's telling us exactly where to put these holes. Those are actually, those pins that Rick are using are precision ground pins, so he knows their diameter. I would tell you that digital readouts make us worthless and weak. Now that we're in here, now we're just cutting off excess width because he was going off the bottom. You can see the parallels up inside the jaws. He was going off that, and now we know that if we cut the top, that once we get it all clean, we have something that's the same thickness on both sides. And do another little cleanup pass here and then cut it completely off. This mill is a thing of beauty. Rick totally rebuilt it. It used to be, somebody had converted it to CNC, and it's got ball bearings on all three axes. I mean, this thing has zero backlash. It's a nice lathe, and it's our mill, I'm sorry, and it's even nicer when somebody that understands how to operate it runs it. I had Rick leave me a lot of room here because this part has to basically be set up with a file by hand, and I didn't know, so we left a lot of fat on this. I'm demonstrating this like this because I don't want to move. I got this thing jigged the way I want to jig it in order to explain it. This is the piece we made, and we're copying this piece. This piece does two very important things. This will make a comeback later. This is out of a 1900s Bannerman, and we're going to see if it works in here, because if it works, we're just going to do an identical copy of it. What goes on is the following. This cartridge, and isn't it nice that they gave us one, because it is exactly the right length opened up, and it gives us something to copy. So when the gun runs, it does this. Okay, as you pull forward, this breech block is going to come and it's going to lock in position right there. And you just heard it lock. The gate snapped down behind that we just built, and we're set. So now when you go to open the gun, this will open and extract, and we're extracting, and that's what we'll show you what that does. So we're in extraction phase right here, and then the gate will fall through, and it's going to line up as we come back forward again. It's going to grab the cartridge out of this slot right here. Clear as mud yet? So the feeding setup is going to be, this has to be grabbed back here and shoved into the chamber. Trust me, guys, I'm getting my arms around it right along with you. Okay, so this device here is going to sit up inside like this. This hole right here lines up with that hole right there, and this whole thing's going to sit in there and ride on the surface. Now, in order to put it in, I actually have to take this out, and I'll do it in a minute, but it sits there, and as we come back, it's going to encounter this lid. And this lid is going to cause that to be shoved down into this space. So let me get this all lined up. I'm going to get a pin stuck through here. I'm going to get a pin to hold that in. And we're going to see if we can't get all this lined up here. Give me a second. I came in and just got a pin here and got this to move freely in the aperture. Now, I'm not fitting the part to the Bannerman gun to this gun. I am just making this work, right, by opening up or closing this aperture a little bit. But no big deal, because then I get to come back in later and make this part fit whatever's left over, and that's what's going to happen. So by not modifying the extractor ejector assembly to the other gun, I know that's still going to work. What we want to know is in its unmodified format, will it work in here? See here, we got to get up in there like that. And we got to get the track lined up, all right? There we go. Okay, so we can see here how it just by gravity, the back end of the receiver here is tucking this in. So that actually is going to fit. So now what I want to see, ordinarily it's going to time off the nose of this plate, but we'll get there. I just want to see if, oh yeah, that stuck it in. That put it in a chamber. So we put it in the chamber, so then when we come, did it put it far enough in the chamber that it put it in there? Yeah, see, now that's got to get up out of the way. And then we got to get this block to come down. So what's keeping the block from coming down? We're not far enough forward, right? So we're not quite timed right. We're not far enough forward here. Or that cartridge is not allowing us to stick it all the way in. Okay, it came in behind it. There it goes. Because I didn't have the plate here, this didn't stay down and it didn't shove it in. So now we've actually got a round up inside the chamber. So then when we come back again, if this is timed right, that should have grabbed it, and it didn't, because the plate's not there. So if the plate was here, the plate would be shoving down on this right now and telling it, see, we're just not, beginning gunsmiths, you bet your sweet bippy I swept the crap out of this floor before we started doing this, so that if I go dropping little eeny weeny screws. All right, so if this is timed right, let me get the lighting right on this. If this is timed right, this should come back. And right now the gate, tell you what, we're gonna do a slight reposition here because I want you guys to see where the head of the cartridge is. So right now, as we're unlocking, I'm just showing all the timing we gotta do to the new part. As we're unlocking, the breech block is falling, and the breech block has just exposed the cartridge before the extractor gets there, and now the extractor is being pushed under by the plate. You see it going down, it grabs the head of the cartridge, and boom, back it comes. Now you got to do this with a little more zip, but that should just roll up and come out. Oh, no, wait a minute. Yeah, that, okay. Now, we're missing a honking spring that when we got there, that was supposed to do that. So we don't have the whole gun in sequence yet, because what we're missing is that gargantuan thing pushing on the other end of it, which makes the breech block always want to be up. You've got to force it to come down. So the moment the button gets behind the breech block and cocks the hammer, up she goes, like that. So believe it or not, I honestly think we can copy that and maybe get away with it. I honestly think we'll be able to copy that. Now, on the later versions of this, they went to one on either side. They went to this, but the timing of this is such that it's got to touch the front of this plate and get pushed under. I think I'm just going to go ahead and make a Chinese copy of that. All right, let me get set up because we ain't doing it set up like this. I'm using the guide pin that machinist Rick gave us. And in his die-cum, I went ahead and, so I'm just going to grind that. He got this thing pretty damn close. So we're going to cut this front edge off. And then we'll go in and we'll cut off this 45 right here. We'll just cut this angle off. And we're there. And then we got to make that little spring-mounted titty thing right there. And we should be able to try to go back in the gun then and fit it. So the rest of this is just going to be grind and file. The rest of that I'm going to do with a file, but I'm damn near on that line. I'm going to go ahead and go the rest of the way in with files. Okay. We know that that curve is pretty significant in this thing, so we'll go ahead and we'll check it. Wow, low dexterity afternoon. Here we go. So we're getting pretty damn close to having it. We're right there. And I'm just going to take the bottom of that nose off, and the rest of it we'll do in the gun because we don't know. Here's the problem. We don't really know how worn this part is. So we're really kind of just getting close. You know, before you make a decision on old parts, you gotta understand. I think I'm pretty damn close. Yeah, I'd say we're there. The rest of it's just going to be polished with some crocus cloth. So I've got that. I got to take a little bit more off. But that was when this thing was sitting in the slide. It had to be, there's a place where it's lined up, and it'd be very difficult to show y'all, but I will try to show you what I'm talking about when we get it in the gun to set it up. Yeah, that's us. All right, now we're going to go to that 45 angle, but I think we got that pretty much there. Wouldn't you say, where's the camera? Right there, right? I'd say we got that pretty much there. There's a little bit left over on the bottom, and then I'll tweak that when I get it in the gun, because I'm not sure I want to take it off right now. So now we'll get that 45 out of there. Hold on. Hold on. Now we got to cut this at a 45 right there like that. I'm in the way. I know I'm in the way. There's no way to do this without being in the way. You know, hi, my name's Mark. You're looking at my left shoulder, but you have to trust me that I'm doing important work. Okay. So all I'm doing now is cutting that 45 off. And I just put it in the vise in such a way that the vise will not allow me to over penetrate. We already know that this particular cut times nothing. It's just metal. It had to be gotten out of the way. So the piece doesn't stop on this 45. It doesn't stop on this 45. It doesn't move on this 45. It's just a 45. It's just there. And it just had to be gotten out of the way. So there it is, right? That's that cut. So now there's some tuning here. This is at an angle. When this is feeding or extracting, it's not trying to push on the rim along the long axis. It's shoving down and trying to push it across. So they thought this out pretty well. All right, let me take this thing apart, and we'll have to make that little piece for the middle. So I've already started sawing down. This is an old blade off of a yard whacker, an edger. So the steel is perfect. We just come down and saw out what we got to saw out, and that's all you're doing is just making a copy of it. Here we're making it thinner because I need it to fit inside. And I mean, that was it. I mean, it's not that hard to do. B-roll notwithstanding, we've cut everything out. So what we succeeded in doing is pretty much duplicating this part. Now, you'll say, yeah, this is sticking out a little bit further than it should be. You're right, and some of the angles may not be there. I've got to hand fit this piece into our gun that we're doing. But basically, we made a Chinese copy of the Bannerman's extractor, and I think we got it. I think we're pretty damn close. We cut all this stuff out of a solid block of steel, and I don't know when I can tell you that I learned how to do this. You just got to go learn how to do it. We put our new piece in, and I got to get this thing back in sequence here, and we'll drop it in. I got to remember here, I got to come back. That's what I got to do. To get in sequence, I got to be down here like this, and then this will drop down, line the cartridge up on the barrel right there. That'll put it in the barrel. Now, this thing wants to be pressurized up, so I'm going to push up on it. As we come back, we can see that the feed pawl has kicked out, which has allowed the spring-loaded part of the ejector, that spring-loaded piece right there has now popped in behind the rim, and it's bringing this out. All right. Now, this case is starting to not like all the handling we're doing to it. But while all this is going on, there's a fair amount. The hammer is being cocked, and the spring tension that's trying to make this thing pop up is showing up in spades. So by the time we get right here, boom, the ball that's driving all this, that round part has come off, and this will go like that, and you eat this shell up over your shoulder. At least that's the operative idea. So believe it or not, we've now fixed two problems. We fixed the shunt, and we fixed the feed pawl / extractor gizzy by making another one. So we made one of these, not for the faint of heart. This one's going to go back on the Bannermans. That's going to take me down to basically one thing that's keeping us from shooting this, which is that whole mess going on with this mag tube, and we don't know how the follower is kept in the tube. I don't know. I know that this non-magnetic zinc thing that they had in there is not a follower, so that Bruno was away. We're on like day 3 of filming this thing, so I had to do a couple of things in B-roll here, and I finished the magazine. The magazine had some dents in it. I went ahead and pounded those dents out, and got the follower to run up and down smoothly without all of the masking tape and sticks and all that other stuff in it. And then the thing we just did, and I got to reach in front here to show you, is this. Up in here, that part that we made right here, this part that has the claw on it, right? When you come back, that claw has to clear, and there is a recess cut right here in the bolt, and that has to go, that recess cut has to be allowed to come up through here, all right? So let's look at this again, and we can see that when the cut gets right about there, nothing's happened, right? So the timing to release the carrier to the full up position is that bolt handle gets far enough back to release, and up it comes. By that time, there's a shell sitting here and it eats it out of the gun, right? That will allow the previously induced round that's on the carrier now to line up with the barrel. Back in you go and you're ready to shoot. So we made a couple of parts for this thing. One was the gate, one was this. The follower, I just took a Remington 870 follower, took a square piece of stock, chucked it on the lathe, glued this thing down, and then cut it to length so that the follower, again, I'm reaching in front here. The follower is sticking in right here, and you can see it being held, all right? The red part of that follower is what's left of the 870, and then the wood has got a slight dome to it so that as this rides over, it'll push that up out of the way if it's the last one. You can't let it stick out far enough that it'll try to chamber itself. You don't want to do that. But we got this mag tube now all cleaned out. I, for years, have had this bronze mag tube hammer, and then I've got one for barrels too, but it's funny. The dimensions of this gun are almost identical to every other shotgun made up to this day, and it's almost like these guys got it right and everything followed, because if you take a look at the front end, all the barrel bands and everything, this is an 1897. It's almost, oh, wait a minute, there was a slight patent infringement case, and these guys lost. Well, okay, there you go. I pounded all the dents out of the barrel so that the follower would just drive down, would just slide down. So that's in there. So what that lets us do, oh look, a pink shell. Breast Awareness Month. Spread the word, guys. Anyway, we've cut this down to the exact right length because we were starting to beat this paper one up a little bit. And you can insert and get up underneath. There's a latch here on this side, right? And that latch, you pop that out, would let that shell go, all right? So, if I come forward, you'll hear the round go in, you'll hear it feed. You hear it, chip, it went back, right? So now if we pull back, that kicks out, the round comes up. We can chamber the round and eject it. We got through it. So now let's look down in here and see what that does. This edge right here, the back edge, is the part that pushes the shell into the chamber. The spring-loaded front edge is what pops back out, grabs the rear end of the round, throws it back, and as soon as it gets clear, the latch ejects it. So as you can see, this was the timing we were talking about right here. And the minute that comes back far enough right there, that's allowed to pop up. This thing's starting to grow on me. When this Spencer came in here, there was masking tape, pieces of dowel rods and old shells jammed up in it. Parts were missing off of it. Springs were broken. Pieces of it were made out of lead that were supposed to be made out of steel. There's a lot going on with this gun. I have to make some black powder shells for it. We don't have black powder shells for it. I cannot shoot this thing. It's made out of iron, but I will tell you what, we did get it to feed and eject. How about that noise? That's pretty good. Also, I got to make a football front end for it. But what I wanted to show you was a Spencer pump shotgun. And what's really amazing about this thing is how they got most of it right on the first pass in the late 1870s or into the 1880s. They got most of it right. So I'm going to tell you, I'm sorry I'm not shooting this one today. I'm going to get this thing out on a skeet field if it kills me, because I'm just interested to see what that would look like. And as always, it's been a pleasure. And beginning gunsmiths, remember to think. Wow, there's a concept. Have a nice day.